These days, many retailers and manufacturers are tracking their products using RFID, that is, radio frequency identification tags. Often, these tags come in the form of paper based labels outfitted with a simple antenna and memory chip. When slapped on a milk carton or jacket collar, RFID tags act as smart signatures, transmitting information to a radio frequency reader about the identity, state, or location of a given product. In addition to keeping tabs on products throughout a supply chain, RFID tags are used to trace everything from casino chips and cattle to amusement park visitors and marathon runners. The Auto ID lab at MIT has long been at the forefront of developing RFID technology. Now, engineers in this group are flipping the technology toward a new function, that is sensing. They have developed a new ultra-high frequency or UHF RFID tag sensor configuration that senses spikes in glucose and wirelessly transmits this information. In the future, the team plans to tailor the tag to sense chemicals and gases in the environment, such as carbon monoxide. As a demonstration, the researchers developed an RFID glucose sensor. They set up commercially available glucose sensing electrodes filled with the electrolyte glucose oxidase. When the electrolyte interacts with glucose, the electrode produces an electric charge, acting as a local energy source or battery. The researchers attached these electrodes to an RFID tag's memory chip and circuit. When they added glucose to each electrode, the resulting charge caused the chip to switch from its passive RF power mode to the local charge assisted power mode. The more glucose they added, the longer the chip stayed in this secondary power mode. A reader sensing this new power mode can interpret this as a signal that glucose is present. The reader can potentially determine the amount of glucose by measuring the time during which the chip stays in the battery assisted mode. The longer it remains in this mode, the more glucose there must be. While the team's sensor was able to detect glucose, its performance was below that of commercially available glucose sensors. The goal was not necessarily to develop an RFID glucose sensor, but to show that the group's design could be manipulated to sense something more reliably than antenna based sensors.